Alright, so today we are doing Unit 1, Lesson 9, Creating Scale Drawings. Our learning goal is let's create our own scale drawings. So we talked about scale drawings on Friday. We're going to start out with a number talk, which is greater. What I'd like you to do is stop the video and go ahead and solve those three without calculating, decide which quotient is larger, and then you can come back and we'll talk about it. So the way I thought of this was I said 11 divided by 23 is kind of like the fraction 11 over 23. Well, 11 over 22 would be exactly a half. So this is a little bit less than 1/2. Okay. Then if I think of 7 divided by 13 as a fraction, well, 7/14 is exactly a half. 6.5/13 is exactly a half. So this is greater than 1/2. So therefore, 7 divided by 13 is our larger quotient. All right, this one, if you think of money, if we take 63 cents and we divide it by 2, and 55 cents and divide it by 3, well, 63 cents is already more than 55 cents. And we're dividing this just into 2 groups, and we're dividing this into 3 groups. So right off, we don't even need to figure that one out much at all. That one's going to be bigger. All right, so this is saying we're taking 15 and we're dividing it into 1/3. How many 1/3 are there in 15? And this is how many 1/4 are there in 15? Well, since this is smaller, there are going to be more of those in 15. Okay? All right, so now we're moving on to a bedroom floor plan. And if you've already looked at the projects for this week, one of them is to do a floor plan. So this kind of gives you a heads up on the expectation. So just like it suggests in the project, do a rough sketch of the room. So we've got a door and we've got some walls. I probably would have added in some windows so that I've got some better measurements. So Noah wants to create a floor plan that is a scale drawing. This drawing is not to scale, it's just a rough sketch. The actual length of wall C is 4 centimeters. To represent wall C, Noah draws a segment that is 16 centimeters long, and the actual length is 4 centimeters. All right. What scale is he using? Well, I like to use tables. So we're going to have the drawing, and then we're going to have the actual. So if the actual length is 4 meters and the drawing length is 16 centimeters, could that be a scale? Could it be 16 centimeters represents 4 meters. Well, what if we wanted to write that more along the lines of what we normally see? Usually one of the numbers goes to 1, so let's take this one and make it go to 1. So what do I do to make that go to 1? Well, I can divide it or multiply it by 1. Divide it by 4 or multiply it by 1/4. So if I do that side divided by 4, I'm going to do this side divided by 4, and that's going to give me 4 centimeters. So we could say 4 centimeters to 1 meter. That would be the scale. Now it says find another way to express the scale. Well, what if I went, let's do drawing and actual again. 16 centimeters, 4 meters. What if I took this to 1? What if I did 1 centimeter? So to get from here to here, I divide by 16. Here to here, divided by 16. That's 4/16, which is 1/4, which is a decimal. So we could also say that the scale is 1 centimeter to 1/4 of a meter, or 25/100 of a meter. So that is another way to express the scale. Could we just double this? Yeah, we could say 2 centimeters to half a meter. As long as you're doing the same thing to both sides, where have we heard that before, you're going to keep the same relationship. All right, so for number 4, it says the actual lengths of wall A and wall D are 2.5 meters and 3.75 meters. Determine how long these walls would be on Noah's scale floor plan. So I'm going to go back to my table, drawing and actual. I'm going to use, let's use that scale right there, 4 centimeters to 1 meter. Wall A is 2.5 meters, that's the actual, so that's going to go here. Now I'm going to look at this and say, how do I get from here to here? Well, I can multiply it by 2.5. If I multiply that side by 2.5, I have to multiply this side by 2.5, and that will give me 10 centimeters. So on the drawing, wall A would be 10 centimeters. So now let's do wall D. Okay, so I'm going to do my table again, because I like my table because it helps me think about what I'm doing with the numbers. I'm going to keep my same scale, 4 centimeters to 1 meter. This time the wall is 3.75 meters. So how do I get from there to there? I multiply by 3.75. If I do it on that side, I have to do it on that side. So I'll take out my calculator and I will multiply, and I will get 15 centimeters. So he will draw wall A as 10 centimeters and wall B as 15 centimeters. Alright, if Noah wanted to draw another floor plan on which wall C is 20 centimeters, would 1 centimeter to 5 meters be the right scale? Well, let's look at it. We've got drawing and actual, and he's wanting to use the scale right here. So 1 centimeter on the drawing represents 5 meters in real life, and he drew this as 20 centimeters. So how did I get from here to here? 1 times 20. So if I do 5 times 20, that's going to give me 100 meters. Now, was wall C 100 meters? Let's go back and look. Oops, where did we do that? Oh, no. Wall C is 4 meters. So does that scale work if he drew it 20 centimeters? No, it does not. All right, so our next thing is, so this we talked about how to go from the drawing to the actual, or the actual to the drawing. And this one we're going to kind of do, we're going to go the actual to the drawing again. We're going to use the same method. We're going to talk about using a table. So it says a rectangle around Utah is about 270 miles wide and about 350 miles tall. So actually Utah looks something like this. So do you all see that if I filled this in right here, it would be a big rectangle with a piece bitten out of it? Okay, so the rectangle around Utah is about 270 wide miles and 350 miles tall. The upper right corner is missing at about 110 miles here and 70 miles here. Okay, so that's the piece that's bitten out. Alright, it says make a scale drawing of Utah where 1 centimeter represents 50 miles. So I'm going to do my table, drawing and actual, and I'm going to start with my wide. So is that, whoops, my scale is 1 centimeter, 50 miles. So now we're going to start with 270 miles, so miles are over here. Okay, I'm going to say what times 50 equals 270, so I'll take my calculator and do 270 divided by 50, and I get 5.4. So then I'm going to come over here and multiply this side by 5.4, and that's going to give me 5.4 for the bottom. Then I'm going to do this again with the 350 tall. So I'm going to write my scale again, 1 centimeter to 50 miles. And I've got 350 miles. So what times 50 equals 350? Oh, that one's easy. 7. So 7 times 1 is 7. So that would be the length of this line right here on my drawing would be 7 centimeters. Then I did need to do the little piece that's bit out, so I go 1 centimeter by 50 meters, because that's my scale, or miles. Let's see, 110 miles. So what times 50 gives me 110? That would be 110 divided by 50 is 2.2. So I'm going to multiply this by 2.2. Whoops. Times 2.2. So that gives me 2.2 for this line right here, 2.2 centimeters. And then the last one is going to be the other piece spitting out. So we got 1 centimeter, 50 miles, and that would be 70 miles. So 70 divided by 50 is 1.4. So we're going to multiply this by 1.4. And that gives me 1.4 centimeters. Okay. Whoops. Alright, so I'm going to come down below because I got some room down there and I'm going to draw it. So I'm going to start with my 5.4 centimeters. Unfortunately, this isn't a flat surface. 5.4 centimeters. Then this side is 7 centimeters. So I'm going to draw the rectangle. I'm going to make this 5.4 as well. And yeah, I ran into the writing, but that's okay. And complete my rectangle here. Alright, now I got to take out that little piece. So that little piece is 110, so it comes in 2.2. So 2.2 is going to put it here somewhere. And I need to measure this down 1.4. So that goes right here. So let's see. So that's down 1.4, so this needs to be 2.2. So I'm going to draw this line right here, and this line right here, and then I'll erase this out, and there's my scale drawing of Utah, right there. Alright. Now they want us to use 1 centimeter represents 75 meters. So we're going to do the exact same thing, except we're using a different scale. So I'm going to do my drawing and actual. So now 1 centimeter represents 75 miles. I'm dealing with the same mileage, so 270 miles. So 270 divided by 75 is 3.6. So that means this is going to be 3.6 centimeters. Okay, same scale. This time we're doing 350 miles. 350 divided by 75 is 4.7. So that's going to be 4.7 centimeters because I multiply it by the same thing. Whoops, I forgot to write that up here. All right. Then we have that little piece, which is 110. And we get 1 centimeter. So 110 divided by 75 is 1.5. So now we're going to multiply this by 1.5. So that gives me 1.5 centimeters. And then our last one, 5 miles. And we want 70, so that's approximately 9/10. And we'll multiply this by 9/10, and that'll give us 0.9 centimeters. All right. So we're going to come down here and we're going to draw it. So we're going to start out with 3.6 by 4.7. 3.6. Okay, and then we're going to come up 4.7. There's 4.5, 4.7. You can't see what I'm doing. There we go. And do the same thing on this side. 4.7. Whoops, that one looks like I went all the way to the edge and I shouldn't have, because that's why we do math and pencil. Alright, 4.7, and I only go to here. And I did something wrong over here. Yes, I did. Alright, so there's my rectangle. Now I'm going to cut out that piece. So I need to go, let's see, 9/10 down. So that's going to take me to here. And then I'm going to go over 1.5. There's 1.5. Right to here. I did this much better than I did the last one. Alright, and then I'm going to erase out that bite. And I'm going to fill in my measurements. So that's 3.6 centimeters, 4.7 centimeters. This is 0.9 centimeters, and this is 1.5. And I forgot to fill them in over here, so let's take care of that. This is 1.4 centimeters. This is 2.2 centimeters. And this side over here was 7 centimeters. Alright, so how do the two drawings compare? How does the choice of scale influence the drawing? Well, this one is obviously smaller than this one. And let's look at the scale. Well, this one, 1 centimeter represents 50 miles. And in this one, 1 centimeter represents 75 miles. So that makes sense that this one's going to be smaller because there's 25 more miles within that 1 centimeter. Okay? So depending on how accurate or how much space you have, or how big your drawing needs to be, is which scale you will use. Alright, so summary. If we want to create a scale drawing of a room's floor plan that has a scale of 1 inch to 4 feet, we can divide the actual lengths in the room by 4 to find the corresponding lengths on our drawing. which is kind of like what I did here. I divided 270 by 75, 350 by 75, 110 by 75. So if we look at this, it says, suppose the longest wall is 15 feet long. Now we're using this scale right here, and I'm going to show you using the table, even though they show that right there. I'm still wanting you to use the table. I think the table is going to be your best bet. Okay, and we know that the longest wall is 15 feet. Is that the drawing or the actual? That's the actual. So we're going to put 15 feet here. I'm asking myself, what times 4 is 15? Well, 15 divided by 4 is 3.75. So that is my multiplier. So I'm going to come over here and multiply this by 3.75. And that means that longest wall needs to be drawn at 3.75 inches. All right, we can use, is there more than one way to express the scale? Sure there is. Think of it as a fraction. How else could I write 1/4? Could I write it as 1/2 of an inch to 2 feet? Yeah, I took half of this and half of that. How about 1/4? If I take 1/4 of this and 1/4 of that, those are all the same scales. Okay, so any of these scales can be used to find actual lengths and scaled lengths, the lengths on the drawing. All right, now the size of the scale is influenced by the choice of the scale. So now we have 1 inch to 8 feet. Well, notice the difference in the two drawings. This one is significantly smaller, okay? And that makes sense because each inch is representing 8 feet, and in this one, 1 inch is representing 4 feet. So this one represents half as many feet. So that's why the drawing is significantly smaller. So sometimes you got to think about how big do you want to make the drawing, how accurate do you want it to be, and that helps determine which scale factor you use. You also have to take into account the size of the paper or graph paper that you're using. All right, so I hope we grew your math brain a little bit. I hope you like using the tables, because I really think using the tables is going to keep your numbers organized and make you do the right operation. So have a great day.